All right, let's take a look at light waves and electrons. And remember that we're trying to express the arrangement of electrons using electron configuration. And in the last video, we saw how we could label the peaks in a PES to write the electron configuration. But this time, we're going to focus on another tool that chemists use, and that is the periodic table. It actually turns out that the periodic table is arranged in a way to reflect the data that we get from PES. And it's arranged into these blocks that are the sublevels. So here you have your S block, this first two columns, the P block, which is the last six columns, the D block in the middle, and then the F block, it looks like it's on the bottom, but it's actually here in between 6S and 5D. And these are the energy levels and the sublevels, and you just label each row, right? So this is 1s, 2s, 3s, 4s. On the P, it starts on the second row, so 2p, 3p, 4p. It does get a little strange with the D block. The D block starts with 3D. And I always just remember that the S block is the first block, so it starts with 1s. The P block is the second block I'm going to see. It starts with 2, and the D block is the third block. It starts with 3. That's just a neat little trick to help me remember. 1, 2, 3, and then the F block actually starts with 4. We won't get into the details why this happens. It's just because of the number of protons and how that affects the electrons. Now, with this in mind, I can find an element and write its electron configuration. So here's sodium. We did sodium previously. And what I do is I write all of the blocks that come before where I'm trying to get. So to get to sodium, I start at the beginning of the periodic table, and I have to go through the 1s, the 2s, the 2p, and then I finally get to the 3s. And then I write down the number of electrons that I had to use to get there. So the 1s has two spaces, 1, 2, that's 2 electrons, and so on and so forth, and we do that. So let me show you this in a step-by-step way. Here, I'm going to try to find the electron configuration for fluorine. Fluorine is number 9 on the periodic table. And the first thing I want to do is make a plan, find the element, and look at how to get there. So to get to number 9, I got to go through 1, 2, 3, 4, 5, 6, 7, 8, and 9. All of those elements. I'm going to actually draw that line because then I'm going to label those lines. And I'm going to label them with the energy level and the sublevel based on the row that it's in. That's going to give me the energy level. And then the sublevel, which block it's in. So I have 1s, 2s, and 2p. Then finally, I'm going to count the number of electrons in each of those sublevels. So in this 1s, I have 2 electrons, hydrogen and helium. The 2s, 2 electrons. And in the 2p, I have 1, 2, 3, 4, 5. So I'm counting the number of elements I'm going through. That's the number of electrons. And then that's going to be my number. And I can always double check by adding up my superscripts. My 2, and my 5 all together make 9. Now, let me show you this in real time for phosphorus. So I'm going to try to get to the element phosphorus. And to do that, I have to go through the 1s, the 2s, the 2p, the 3s, and the 3p. And I'm going to label those. So this is 1s, 2s, 2p, 3s, and 3p. And now I just count. In that 1s, I have 2 atoms, so 1, 2. In the 2s, 2. In the 2p, 1, 2, 3, 4, 5, 6 to get to neon. In the 3s, 1, 2 to get to magnesium. And then in the 3p, I'm trying to get to phosphorus, so I only need to go 1, 2, 3. And then I can write all that out, and that'll be my answer.